everyone, my name is Nur Balqis Iqwani and I'm a student from the Diploma in Microbiology program, and this video is for the course CHM207, and today I'll be presenting about alcohols, and I hope you find it informative. When people hear the word alcohol, they think of social drinks, but in the world of chemistry, alcohols are a massive family of organic compounds that keep our modern world running. So, without further ado, let's look at the functional sides of alcohols, from the fuel in your cars to the metabolic processes in our own bodies. Structurally, what makes an alcohol is the hydroxyl functional group, or the minus OH, bound to a saturated carbon atom. Look at the structure. This isn't just a bunch of atoms, it's a master of disguise. Because alcohols have that minus OH group, which means that they are amphiphilic. They love to be around water, and they also can hang out with oils. Using digital molecular modeling, scientists can tweak these chains to create everything from the ink in your pens to the coolants in your laptop. It's chemistry's most versatile building block. We commonly deal with ethanol, methanol, and also isopropyl alcohol, each serving a very specific purpose in industry. In industry, alcohols are the Swiss Army knives of chemicals, since they can be used as solvents because they can dissolve in both polar and nonpolar substances, and they are the base for perfumes, paints, and lacquers. As fuel, ethanol is a primary biofuel. In many countries, petrol is blended with 10% or even 85% ethanol to reduce carbon emission and boost octane ratings. As antiseptics, isopropyl alcohol is what you can find in your hand sanitizers. It works by denaturing the proteins of bacteria and viruses, effectively melting their outer layers on contact. And it's not just about factories, our bodies also deal with alcohol compounds constantly. For metabolism, when human consumes ethanol, the liver uses enzymes like alcohol dehydrogenase to convert it into acetaldehyde. Other than that, did you know that some alcohols occur naturally in plants as sugar alcohols like sorbitol and xylitol? These sugar alcohols are used as low-calorie sweeteners because our body processes them differently than glucose. For fermentation, microorganisms like yeast produce ethanol as a metabolic byproduct, a process where humans have harnessed thousands of years to produce bread and beverages. To study these compounds today, we use advanced digital technology. Tools like GCMS, or we call it as gas chromatography, mass spectrometry, allow us to detect alcohol levels in blood or environmental samples with pinpoint accuracy. Furthermore, molecular modeling software helps chemists predict how a new alcohol-based drug will interact with human cells before it ever hits a lab bench. In conclusion, alcohols are the unsung heroes of the periodic table. Next time you use a hand sanitizer or see a hybrid car, remember, you're looking at the power of the hydroxyl group. I think that's all for me. Thank you. Thanks for listening, and goodbye.